Cool. Well, why don't we get started since folks are starting to roll in here, and I'll keep an eye on the attendees and get him set up. So, appreciate you guys spending time with us. WebAssembly is one of those things that has been frequenting the halls of Twitter, and the now 1,000 member strong yet another infrastructure group. And what I was hoping to do today is one, bring together some of the best minds in and around WebAssembly, and then one, introduce WebAssembly and talk about why it's important. Discuss where WebAssembly is optimal in terms of use cases and applications, and then also identify some of the obstacles and necessary breakthroughs for it to achieve mainstream. And so with that, why don't we just go around the table, do some quick introductions, just like who you are and what you're working on, and why you have a good take on WebAssembly, and then we'll kick it off with some questions, many of which have been supplied by our audience. I would appreciate that. So Matt, why don't you kick us off?
Sure. Yeah, I'm Matt Butcher. I'm one of the co-founders of Fermyon Technologies. We're doing WebAssembly on the cloud side. The brunt of us came over from Microsoft last November and started Fermyon after doing some sort of exploratory research earlier and finding that WebAssembly was just solving a lot of problems we were interested in solving. I can hand it on. Next person over next to me is Connor. So,
sure. Yes, my name is Connor Hicks. I founded Suborbital. It's one of the other contemporary WebAssembly startups in the space right now. Suborbital started out as some open source projects that I was working on. I was at 1Password for a long time as a developer, and decided that WebAssembly was exciting enough to leave there and pursue it full time. So we've dabbled in building WebAssembly backend frameworks. We've focused most of our energy on extensibility, so using WebAssembly as a plugin system. We focus our efforts on the backend as well, so SaaS applications and backend development.
And I'm Randall. I'm the chair of the CNCF Cloud Native WebAssembly Day. I'm also the co-founder of both Wasm Cloud, which is an open source project originally launched out of Capital One, as well as Cosmonic, which is building a distributed Wasm PaaS. My background was a serial entrepreneur, and I sold the first Kubernetes company called Critical Stack to Capital One Bank. And I became aware of the friction of running forest of applications when, after a promotion, I owned all open source. And WebAssembly, we thought, was one of the most promising technologies out. I met Matt on the Microsoft team and started collaborating with a ton of other folks, and have really believed in the community and the journey and the future of WebAssembly.
Does that leave me?
Go for it, Martin.
So I'm Martin, and I know the least of anybody here about Wasm, but I'm very excited. So I'm going to learn with everybody else that's listening. So that's kind of my position here, is to learn with y'all.
Likewise, call me a curious onlooker and somebody who wants to better understand the technology at a much deeper level. So with that, why don't we just kick it off with just like a very straightforward question, which is what is WebAssembly and why should we care? And why don't I kick that off to Liam first, and then either Connor or Matt can ask questions after that.
Sure. WebAssembly is a really simple idea, one you're probably familiar with. It's a compilation target. And if we think of it as something similar to what Flash and other web-based technologies did before Silverlight, it's a simple thing. What's amazing about WebAssembly is that it's an open W3C standard that, like many web technologies, has as much opportunity to disrupt the way we build software as things like JavaScript did. So it's the technology that's, if you think of it as the world's smallest virtual machine, it's a technology that can live above containers. It can live compatible with containers. It can also live in places where we don't traditionally have CPUs. I could go on and on about this, but why don't I pass to Matt or Connor, and one of you guys can pick up and extend the vision a little bit here.
So Cosmonic and Suborbital and Fermyon co-authored a blog post identifying why we're excited about WebAssembly. And in there, we kind of identified 3 big use cases where we see WebAssembly starting to get traction in exciting and interesting ways. One is obviously the browser case for which it was built, right? If you rewind back to when Luke Wagner first announced the project, the language he talks about is being able to use it in the browser. When Brennan Eich was talking about it back then, it was always bet on JavaScript and WebAssembly, right? But we've started to see WebAssembly as a virtual machine and compile target start to move outside of the browser. And the other 2 use cases that we think are very promising and that we talked about in that blog we all co-wrote were plugins. One person called it the last plugin model you'll ever need. We all know from technology that there's no such thing as the last anything that we'll ever build. But the idea is very compelling, right? That if we can embed this virtual machine, that's a very extensible one inside of projects, then we'll be able to build all kinds of plugins. And then the last one is really what it can do as a compute engine in the cloud, which, all 3 of us have worked. Cosmonic, Suborbital, and Fermyon have all worked in that domain as well.
Martine.
So I just, as we're going through this, and maybe it'd be great for Connor to speak, but then do you mind just like engaging me in a conversation after, just so I can kind of understand why Wasm is Wasm? Because I've got these open questions. So Connor, it would be great to get like whatever color you want to add. Then I think like for those of us that are like unwashed in this, there's some very basic questions of where this sits in the stack. Is that cool?
Yeah, for sure. Yeah, for me, WebAssembly is all about allowing you to run software that's extremely lightweight and yet has some of the best security properties of a runtime that we've seen in a long time. That's one of the reasons why I got so excited about it. I mean, I did security design and stuff like that at 1Password, and so those properties of it really drew me in, and allowing you to be pretty damn sure that when you're running a piece of code that it's not able to, affect the infrastructure that it's running within is a very powerful concept. So being able to run untrusted code, being able to run things that, come from authors outside of your own organization in a safe way, and having really, really tight control over all of that is what's, most exciting to us. But, the fact that it allows you to do that while still having very good performance and having support for such a wide variety of high-level programming languages is really just incredible. So let's have a conversation.
Okay, great. I just want to ask some like super basic questions just so that I can level set. And I'm guessing other people that like aren't exposed will have the similar questions, which is, I think my biggest early question is, the history of language independent like bytecodes is not great. And you could, everything that you've said, every single one of them, including like looking at Flash, you could do by actually with a language. And this includes actually having a virtual machine, right? Like when we ran Java applets, we ran the JVM in there, and so my big question is why would you decouple this from the language? Because there's a lot of pretty, like the actual language the programmer uses, because some pretty obvious downsides. And I can think of one very strong upside, but like not many more than that.
Well, I think there's the decoupling's not only above, it's below. When we think about containers, for example, containers have an incredibly tight coupling to Linux. The security model is coupled to Linux. So WebAssembly was a clean slate approach to what would it look like to build a runtime that was denied by default, that was truly independent of the operating system it was running on, of the CPU it was running on, and gave us a compilation target, so an execution domain. So
I get that. I'm 100% with you. It's great to have an independent container. My question is very specifically, which is like, if you're doing like whatever, like going back to Java applet days 20 years ago or something like that, you say all of the same things, but the big difference is that it was coupled, like the actual virtual machine was coupled to the language. And there's a very specific decision which makes Wasm Wasm, which is independent of the language, which historically, I mean, going back to even the transmeta days, like way back when in the chips, is like not really worked. And so I'm just wondering.
I think I dispute your supposition that it hasn't worked. I think Java actually shows, and as does the CLR from .NET, that it has been, in fact, relatively easy to build bytecode interpreters that host more than one language, right? Java, Kotlin, Clojure, you got a whole bunch of languages there, right? And .NET, you've got a whole litany of other languages. I thought
that was like mono-failed C#. I mean, I just feel
I wouldn't say mono failed. I think mono's doing quite well, having just come out of the .NET world at Microsoft. I think maybe we'll hit an impasse here on what we qualify as success or failure. But my kind of thinking would go that Java and .NET have both demonstrated fairly well that you can create a bytecode runtime that supports multiple languages. Now, the way the ecosystems evolved with Java and CLR, Java comes first, right? Java, the VM is built just for the Java programming language, and it takes probably 7 to 10 years before you start to see any of the second tier languages start to I think Groovy was the first one I ever used.
First time I used Java was in '98. I was like,
I was a Java 1.0 person, so
that's right, like forever.
I think what we're actually seeing is the kind of evolution we're used to seeing, right? That Java sort of really paved the way. It was the first VM language that really caught people's attention and then entered the mainstream. And then from there has shown decade after decade that it has staying power. But it was sort of like the Petri dish in which we learned a lot about JIT and we learned a lot about AOT compiling and we learned about designing languages for runtimes. CLR and .NET comes along a little bit later. Their initial foray, we're talking about, well, we can run Java or whatever Microsoft called Java, J++ or whatever it was called, and C# on the same CLR. So they were initially coming out of the gate saying, well, we're going to target multiple languages compiled to a standard bytecode. Still, we got about a decade and a half of key learnings we've gotten out of that. And I think, if you talk to the people who worked on the specification for WebAssembly, they nerded out on every piece of research they could find and began building something that they felt like was just kind of an iteration on that kind of common bytecode format. And there are definitely some trade-offs they made on that, right? Are they the right trade-offs? I think Liam and Connor and I would say yes, but it's of course open to dispute, and it might take us, as ecosystems go, it might take us a decade to realize what the real key shortcomings were. But right now, it's looking fairly rosy on that side, I think.
The Datadog report has some phenomenal, broad industry representation around what's the most fastest growing part of the serverless market. If you haven't, I'm sure you've looked at their serverless report when it comes out. But when we look at that report, the area where there's the most growth is in short-lived functions. And of course, for serverless design, that sort of makes sense. So take the other side of this. If you're a team, let's say you're in a big enterprise and you own the platform that all your developers are going to build your 5,000 or 20,000 apps on, it becomes very hard to think about. You don't want to take away options from your developers. But if you could have a common set of tooling that would let you provide an ecosystem and let people choose whatever languages they want to innovate in, I think that's a good start. The longer term vision, though, with WebAssembly really goes well beyond just being a compilation target. There's this concept of, now that we are compiling to the same place, we can truly have composable components. This idea that we could have components that are implemented in Rust and then enriched by user land code or developer code that's written in Java. So there really is, I think, a lot of excitement and promise for those people that have built and operated in teams of 10 or 20 or 50,000, where you have to sort of think about, how are we all going to get along together? And that was really what caught my eye from the WebAssembly perspective.
Can I just ask one more question, and then I promise I'll step back. By the way, Matt, I thought your answer was so good. Like, I think you're I thought it was fantastic. Like, there really has been an evolution. We've been getting better at this, and I think I missed that, and I think that was fantastic. And then Liam, I totally agree with you that, like, absolutely the nature of the way that we think about deploying functions, it's stateless now, and so like there's just less requirement on the language anyways, and so it's probably even a different time to do that. I totally buy that. That said, just one more quick thing, just so I understand, like, it did feel like both of these cases that you brought up, that actually had a language that people were spending a lot of time on, making sure it did like the long tail of stuff developers want to kind of lead the way, and it did take a decade. And like, Do you think we're ever going to see a Wasm native high-level language, or is it so anathema to the community, like it's bytecode or die?
Yeah.
I'll let Connor go for this one because I know they've worked on.
Yeah, we have already seen some high-level languages. So Grain is a great example of this. It was designed from the ground up for WebAssembly. And we've seen others like AssemblyScript that they see the constraints and they see the benefits of WebAssembly, and they think to themselves, okay, I think I can design a language that is specifically designed to take advantage of this new format and this new runtime. And so, whether or not those languages will become uber mainstream, I have no idea. But the fact that we can have this common target, right, where you could write some Python, you could write some Ruby, you could write some Go, and then it can very seamlessly interoperate with these, specialty languages like Grain, I think means that adopting it piecemeal is entirely possible. Adopting it wholesale would also be possible. It's going to be pretty much as flexible as you can imagine if the design and the goals of the YAIG group come to fruition over the next couple of months. So I think there's a lot of promise, but I have no idea if there will be a mainstream WebAssembly specific language or not.
That's awesome. I had no idea, actually. Please, Chase, go ahead and jump in. I'll shut up now.
No, this is great. Keep
solid.
asking the hard questions. This is the
No,
goal.
I literally want to know. I literally just
Look, I think
I'm a curious kid, right?
I think if you're satisfied with the sort of innovation that's happening above the interpreter, I think one of the main things that inspired me to go all in on WebAssembly was this sort of understanding about what's going on below. When we think about the tight coupling that containers bring to Linux itself from a portability perspective, and a specific CPU that you're compiled to, and finally a security model that's driven around Linux, it doesn't line up with the world. The last 10 years were driven by this great lift and shift into the cloud, and a tight coupling with Linux and where applications were already built for was an advantage and what we wanted, because the things that were running on hardware could be simply lifted and shifted. But when we think about this future world and the long tail of moving out towards the edges, it's not just the data being out there that's driving us there. It is performance. It is regulatory and compliance. In China, for example, you can no longer take data out for processing or for computing, and that means you're going to be running on a local cloud. So there are just more and more compelling reasons, making all the dumb things in our lives a little smarter, that we want to be able to take code and have it have a real set of portability, and even to challenge this whole idea that there in the near future that there's a real difference between front end and back end code. WebAssembly runs just fine in places where there aren't CPUs or operating systems like your browser. And the amazing thing is that it's already there. That is the one part of WebAssembly that may not be hype, is this is already supported in all the world's major browsers. Amazon did a blog on running this on 8,000 unique television manufacturers' devices and so forth. This is a technology that's here today, and major enterprises like Adobe, Amazon, BMW, and others are investing massive amounts of money in new roadmaps and products. More importantly,
can I just poke on that just a little bit, just honestly, just so I understand the thinking? Which is, so yeah, I mean, as people may or may not know, I used to run network and security at VMware, and so I spent an awful lot of time in like the virtualization space, and like virtualization is very, very, very powerful technique that we have in systems. In any number of ways, but one thing it doesn't do is it doesn't paper over architectural differences of where you are on the stack. And like there's no API that'll do that. Like if you're a developer and you're developing something in a browser versus like on the CDN tier versus the server, you're just developing different things because like whatever, the communication between nodes is different, the amount of memory that you have different, like the assumptions are different, the turn is different, right? So do you think at any point the generality of WASM becomes a bit of a negative because it doesn't choose one area where it's best at? Like we are just the browser technology, we're just because I do think that there's a lot of stuff that you want to implement as far as like helper libraries and stuff that actually depend where you are.
Yeah, I think it's possible that it could become a bit of a mess, but the work that the standards communities are doing right now, I think is going to obviate a lot of that. And the ability for, you know, a WebAssembly module itself to broadcast, hey, this is what I need and this is what I'm giving you, right? I'm providing you these capabilities, and in return, I need these capabilities from you. And having a shared language that we can go across the web, go across the server, IoT, and whatever.
Maybe let me just, my question is a little ill-formed, and I just want to make sure that I'm setting up to answer it correctly. So like the question specifically, which is, if I'm writing code for a CDN tier versus the browser versus the server, I'm writing very different code. And like the types of libraries that I want, support I want is going to be quite different, right? One's probably bring down. I mean, you get that. And so my question is more specifically, like if someone is making a decision to write that specific code, do you think that Wasm's generality becomes an inhibitor because it hasn't doubled down on like the things that are good about that tier? Or is that something people are addressing, saying like, this is just Wasm for the browser, like it's good for that. This is, you know, which of course you lose portability in this case, but you gain the fact that, you know, you actually can support different workloads in different tiers.
Yeah, so you know, if you're writing code that's meant to run on, you know, Cloudflare workers, and then you have somebody sitting at the desk next to you who's writing code that's primarily designed to run in a web application, yeah, there's going to be different styles there. But the nice thing about WebAssembly is that the platforms can actually start to take on some of the burden of figuring out what should run where, right? So if I've written a bunch of code and some of it is designed to run on a server versus a CDN versus, you know, versus an end user device with or without some kind of user interaction, the platform and the modules themselves can collaborate to figure out what needs to slot into what place. So it's an idea that I've heard called the programmable network, or, you know, the real full stack, right? There's this idea where you have a monorepo, you have you know, a whole code base, and like Liam was saying, it kind of blurs this line between front end, back end, like whatever. You just write the code. You need to fetch an image. Okay, can that code run in the browser? Well, the browser will let you know if it's able to run that thing based on the capabilities it has. The CDN will tell you, and then things should eventually one day be smart enough to just slot themselves into the right place. Now, is it possible that this is going to become a complete mess and nobody will understand how it works? Possibly. You know, if everybody in this room, plus, you know, the legions of people working on the standard, do their jobs right, then hopefully we'll avoid that. But, you know, the fact that WebAssembly, even though it was originally designed for the browser, was still designed to be just a generic stack VM, I think in the back of their heads, even though they knew this is, you know, going into the web browser first, I think in the back of their heads, they knew this was going to have, you know, applications outside of that.
I think, Martin, I appreciate your point around the architecture. The application you're building needs to be cognizant of the domain it's going to operate in 100%. But let's even take a more simple example. You know, look at the innovation that's happening in CPU land right now, where in AWS, you have these new Gravitron CPUs. The vast majority of enterprise applications cannot take advantage of those today because whole organizations need to build new CI/CD platforms. All their controls all need to be spun up. All of their monitoring for every language, all of the integrations, the frameworks all need to be updated. I own that problem for a major bank with 93 million customers. And I'm telling you, they still don't have those arms in production outside of anything except one of our open source projects, you know, and WebAssembly. Like the reality is that technology moves faster than development teams can. And if we can have these shims that free us from some of the assumptions that we've carried forward in the past, it has the opportunity to disrupt the world in the same way that virtual machines once did, and containers, clouds, and Kubernetes did after. It's an abstraction that continues. The pattern recognition here isn't, this is just what came before. The pattern recognition is, there's a common layer that we no longer need to burden developers with. And here that common layer is, what is the deployment architecture going to look like? And yes, you could argue, well, if there's 50 different options, we could build 50 different CI/CD pipelines. That's a huge uplift as well. If you're thinking about the responsibility to bring an operating system and all of the operating system controls and that never ending cycle of, oh, I'm going to run all this myself and build the whole stack. WebAssembly is a reboot, and it is compatible with the past, but it's not dependent upon it. You can run it in Kubernetes. You can run it on containers. You can also run it on plain hardware. You can also run it on ARM32. And I would note that one of the awesome things that Matt's company Fermyon and Cosmonic share in common is, we actually don't orchestrate our products with Kubernetes. And I founded the first Kubernetes company, and and Connor as well. I think that that level of independence really frees us to pursue a different future that's compatible with where we came from, because that's necessary to bring people to the future. But it opens us up to all of these new options.
So I've got one more question. I actually have to hop off the half hour, but
didn't you say that the last two times?
Okay, this is actually the last one, which is actually, I think this is a great answer that brings up a very important point, which I thought you'd touch on, but you haven't, which is I do think that new platforms, like if they're entirely new, it obviates basically entire ecosystem, all the old code bases. And one very, very obvious advantage to me of Wasm, which is like, I think one of the reasons like this alone would get it adopted, is the fact that you can actually port existing code bases. And so I was just doing a little bit of like searching last night, and I always kind of look for these magic moments. And like the magic moment I saw was like people like porting shit like Postgres. Like it's like real stuff is being ported. And so
all of PHP.
it's crazy, right? So this to me is like, I mean, this is like alone enough of an advantage to, you know, I would think that, you know, this is gonna be quite successful. And so, you know, I guess it's not as much a question as I would love to hear how existing code base porting is helping drive Wasm. And then unfortunately I got to hop off because I did some stupid scheduling. But I will leave you with that. I really appreciate all of you taking the time, and Chase, it's over to you now, okay?
He's gone, but the question still lingers, so someone will take it.
That was a classic mic drop moment right there.
Connor, do you want to start on that one?
I don't think I do.
I can start on that one. I think so. So when you start approaching questions like this about reusability, you can start thinking about this along different layers, right? The first one is, being able to reuse the programming language we already learned, right? It would be, while it is cool that we're having projects like Green and things like that, it is also equally cool that Python, Ruby, .NET, Rust, C, all of these, Java are all on their way toward being able to compile, because that means, hundreds of thousands, if not millions of software developers will be able to take advantage of their existing knowledge and be able to just apply it cleanly. Right. So language reuse is really the top of this kind of, or maybe this is the bottom of Maslow's hierarchy of something or other having to do with. But the next one up from there is libraries, right? And this is where WebAssembly starts to break out of the mold, because, in the short term, we're going to have per language libraries that can't run in WebAssembly as we're finishing up some of the last bits of WebAssembly, like the threading model and the networking stack. But already, we built our CMS Bartholomew. We built that on top of, it's built in Rust, and we just used off-the-shelf libraries. And, YAML library, yeah, it just works. Rye, the scripting language, yeah, it just works. Handlebars, the template library, yeah, it just works, right? So we're getting a second layer of sort of reusability, and that's that we can use the libraries. Now, here's where WebAssembly differentiates a little bit, and then I'll hit the top layer of this, right? The component model, which is what we've actually been talking about, this layer that'll allow one WebAssembly binary to access the exported functions out of another WebAssembly binary. That will start allowing us to do something we have not been able to do well in the past. And that is that it doesn't matter what source language a particular library was written in. If we can compile it to WebAssembly and export the functions, and another language can import the functions, then suddenly your high performance, Rust YAML library, I can use it in my, learning Python kind of style of scripting, and get all of the benefits of that without ever having to know a thing about what the actual source language was. So I think where we've seen in the past, this proliferation of, NPM for JavaScript and, Composer for PHP and all these different Maven for Java and all these different package management systems that are each filled with re-implementations in a language of the same algorithms and the same stacks and stuff like that. Suddenly we'll start to see wasted effort go away, because we'll be able to reuse standard sets of libraries, and we can stop worrying so much about interoperability between the JSON parser in JavaScript and the JSON parser in Go. And that's a really exciting proposition, right? But then we still have one more layer of reusability, and that's the one that Martine kind of highlighted there, is that we are getting closer and closer to being able to wholesale compile entire applications from intended native or intended bytecode format A, and be able to just compile them and run them inside of WebAssembly. SQLite's really exciting because that's one we all know how to use, and we'll have a whole broad range of use cases from running in the browser to running in plugins to running in the cloud. But it's equally exciting to see things like Postgres and things that are considered big, burly applications that have hundreds of thousands of lines of code and have been maintained for decades and decades, and suddenly have them like show up in the WebAssembly ecosystem. That's pretty cool. But I really do feel like in the short term, and by short term, I mean, 1 to 3 years from now, we'll see most of the application level stuff being largely greenfield development, right? In the sense that you'll be writing brand new code, even if you're reusing existing libraries and existing languages.
Well,
Yeah, that's
and so,
sorry, go ahead.
I was going to say, you mentioned plugins, and I want to put a pin in that and come back to it. And so we're already discussing some of the dice that have to fall before we get to mainstream, and a lot of the questions that came from the YAIG community are about like, what are some of those obstacles? You mentioned language reuse, you mentioned libraries, like what are some of the other things? Like, is it standards? Alex Clemmer had a good question here. What are the biggest obstacles to adoption? Lack of capabilities, lack of standards, lack of buy-in, or something else? Like what other dice do we think still need to fall before we can start getting into like, we'll see some more mainstream adoption?
Yeah, there's a couple that come up pretty commonly, and all of these are being worked on actively. I don't think any of the major problems aren't being worked on, because everybody who's investing a lot of time in this know what they are. But debugging comes up a lot. Having an easy way to actually dive into the running module and see what's going on in a common way that's supported across all the languages. That's a common one that comes up. There are some standards proposals that have yet to land. Things like standardized networking has been in progress, and we've all seen it working, and it is there, and it's coming along, but it's not quite there yet. Threading, garbage collection, like these are all things that have been in progress and are working. So that's like kind of the standards bucket, making sure that all of those things land and get finished. Language support is one that I'm worried about less and less as time goes on, because every week it seems like we have a new, a demo or a new branch of language, or official builds of languages that support WebAssembly. So that I'm not concerned about so much anymore. And then, on the topic of adoption from like companies and people, that's also something that I worry about less and less as time goes on, because we see things like, Prime Video, Disney Plus, BMW, and all these, large organizations dumping tons of effort into it because they see it, they have that light bulb moment, and they say, I can do this crazy complicated thing that I've been trying to do in the browser for years with JavaScript, and all of a sudden I just, compile this 15-year-old C++ library and it just works. Like when they have that moment and they find a real application for it, it's a pretty straightforward answer. So there's definitely, like you said, dice that still need to fall. And library support and standardization and the differences between WASI versus non-WASI targets, like all of these things still need to happen. But as far as I can tell, and I think Liam and Matt will agree with me, is like they're all headed in the right direction.
Yeah, I would come back around and reiterate. I think in the short term use cases under the WASI bucket, which is the WebAssembly system interface. So think of WASI as like, for those that are new, if we think of WebAssembly as a standard as our virtual CPU, WASI is our virtual POSIX environment, our first little mini OS that gives us a base set of capabilities that languages can use for building on top of. So under the WASI bucket, the two biggest next things are networking, threading. But importantly, this WASI snapshot comes out here shortly that has the first pass at like the standard POSIX environment, file systems and files and stuff like that. So that I expect will drive an additional amount of short-term excitement around this. Past that, I think there's another standard that's called the component model that is really critical. And all three of us use the component model now. Think of that as sort of the way that we define these contracts and interchangeability between the various layers here. So if WASI is our OS, it's actually built out of standards that are defined in the component model. But what the component model really unlocks is the ability for us to now start innovating and bringing things to the community in a standard way that don't require us to continue to evolve the standard. And ultimately, I think where this really ends up going is WebAssembly gets adopted and used whether people want to use it or not. Like, who on this call could say whether they're using LLVM or not, right? It's just a piece of the world middleware infrastructure that happens in compilation chains. And WebAssembly is the one tech that you're going to use whether you like it or not.
And I think I'd add one more thing on there, because it gives me a chance to opine on something that that Alex, I think, is kind of thinking when he asks this question. When we witnessed the rise of Docker, one of the really interesting things about Docker was that they evolved very, very quickly. And then we hit this point where all of a sudden people started saying, but wait, now we've got a thing that's critical for infrastructure, but there's no standard, right? Anytime the Docker engineers want to change something, they can, and we all, run a risk that it could break. And there was a whole sort of like brouhaha moment for that. And I think it was like 2016, 2017. In some sense, WebAssembly is almost overcorrected to the opposite extreme. In the sense that WebAssembly started 5 years ago as a W3 standard, right? And every single proposal for WebAssembly goes through the standards process. And standards bodies are slow moving. Actually, I wrote about it earlier this week. I'll drop a link in a second. But that ends up being equally as challenging because if it takes 2 years to work the threading standard start to finish, or 2 years to work the network standard, 3 years or whatever to work the network standard start to finish, that's as some people would construe it, that's 3 years when we can't do something we want to do, right? Component models definitely helping with some of that, but the fact remains that we have to start thinking, okay, some things are going to be down the road a little bit. And that sort of forces you into a mode of design where you say, okay, what can I do today? And does this solve critical things today? And are there places where I can creatively bridge the gap from what I have today to what I want tomorrow? What can I build? And honestly, all three of our companies began with those kinds of questions, because we all started working on this stuff years ago, right? When we didn't have even WASI core was not quite solidified. And it has been a design challenge. But the cool thing is, as we've gone, we've started saying, wait a minute, already we can build a whole bunch of things. And in a way, it's forcing us to ask some better architectural questions. For my team in particular, it forced us into saying, okay, how do we want to run these things? Starting right now, we can't necessarily build the kind of classic microservice. Do we want to go into microservices? If so, how do we build those? And that got us looking at functions as a service and various serverless techniques, and even looking backward toward what the early days of the web with CGI and Apache mod designs and things like that. And that got us kind of into an exciting new mode of development where we went, oh yeah, we can solve these things. And actually we can begin really emphasizing performance, and we can begin optimizing load times and things like that. And it started to open up some opportunities. So in a weird sort of way, standards bodies moving slow has forced many of us to get more creative with the way we design things. And at the end of the day, I'm actually a big defender of slow standards processes, because these are the kinds of things where if we do architect things correctly, right, and with a lot of thought and with input from a lot of very knowledgeable people, then we avoid some of the churn that we have all, I think probably every single one of us has experienced the underthought out implementation of something, and then the churn that happens when you're going, well, now we have to re-architect the API, we have to re-architect the IO layer, we have to really think about CPU usage. But when some of that is handled in foresight, I think we can avoid some of those on a piece that we all think is going to be a critical infrastructure piece.
Well, so I think one good place to shift the conversation would be towards some of the applications and some of the places that we're seeing WebAssembly used in practice. One one of the statements that came up earlier, one of the ideas that came up earlier is the idea of using it to create plugins to make software more extensible. This could come in the form of, unaudited third-party dependencies or user-submitted code, such as plugins and user-defined functions. I mean, we're even seeing people do stuff in, with databases, and we probably can't, have this conversation without having one more buzzword around, like, DuckDB. So maybe one of you all can weave that into the conversation as well. But like, what are some of these applications, and how excited should we be about, plugins as a use case here?
Well, first I would want to point out that Connor's company and Connor's open source project is one of the leaders in creating a plugin model that you can adopt and leverage. And his company builds a platform. I'd love for him to chime in on that in particular. But to take a step back, WebAssembly's inherent security model, its independence from an underlying operating system, make it ideal not only for the kind of portable things that we've been talking about so far, applications that are portable across CPUs, edges, and browsers, but also to be embedded in not only other applications, but in databases. Single Store did an incredible presentation. They were the first company I know of that embedded WebAssembly into their theme, into their database, and it sort of evolved on this theme that I think that WebAssembly is riding this wave of bringing our compute to the data. When we think the themes that I was trying to emphasize earlier were around compute moving out towards the edges and into our lives and closer there, and WebAssembly is a natural place to ride that. But those properties of being highly secure and independent and portable and small and having slow startup times also really lend themselves to the plugin use case. And Connor, I'd love for you to maybe pick up and continue the conversation from there.
Totally. Yeah, this is kind of what we live and breathe, and we think about this a lot. So there's this overarching idea that, data is big, programs are small. So why are we moving our data to our programs when we could be moving our programs to our data? And this takes a whole bunch of different forms. The database one is like the most extreme and probably one of the coolest. But it can also be, something as simple as, hey, I'm using this SaaS provider for, processing images, and I'm using this SaaS provider for processing, my metadata. Why am I having to shuttle data from one to the other, which is possibly in two different data regions in two different parts of the world, when I could just, give a small executable to them and say, hey, please run this for me. And, if you take it down to that tiny little, the smallest unit, which is, hey, I've got a database, and that database is full of rows, and I want to just run a quick computation on the data in that database. Why am I connecting to it with a TCP connection, sending queries over the wire, bringing it back, copying all that data into memory, and then running an operation on it, when I can just say, hey, database, here's a little program, run it for me. And there's a lot less bandwidth that has to take place. There's a nice contract that can be withheld because, as we've already talked about, WebAssembly has a very strict set of imports and exports that it lays out very clearly, and the security model is just, it is perfectly suited for this kind of thing. If I, run a plugin and that plugin tries to do something malicious, like access, my passwords file, or it tries to, access my internal network, if I just don't give it those capabilities in the first place, the syscall just does nothing. It'll probably crash. I don't know, but there's tons of different variations of this problem, right? So one of the most common tools for APIs is a webhook, right? A webhook is, something happens in service A, it sends a message over the wire to service B, which receives it and then does something else. And, this is one of the weirdest phenomenon, like one of the weirdest things that's come up, because there's no really well agreed upon security model. We're sending data over the public internet. There's just a whole bunch of latency and security problems that arise from webhooks. So it's the same kind of thing with the database. Hey, why can't I just give you a piece of code to run when an event happens. And if I then want to shuttle data out because I've determined that it's necessary, sure, go ahead, give me a network capability, allow my WebAssembly module to access that capability, and I will, you know, as needed, send some, maybe it's just the resulting metadata or a, you know, here's a couple of pieces of information that are needed from this larger operation, but don't shuttle tons of data over the public internet and, you know, cost my AWS NAT gateway, you know, tens of thousands of dollars a month. Just take this tiny little, you know, megabyte sized WebAssembly module and do it yourself.
And that starts to open up a conversation around some of the places where you want like lightweight applications and you're in low compute environments, and you start seeing a lot of applications around like edge and areas like that. And I believe it was Matt who had an interesting quote here. Let me read this. So like, you know, VMs are the heavyweight class of cloud computing, containers are the middleweight class. WebAssembly is a perfect fit for the lightweight class. And so maybe one question is like, where's the line between the lightweight and the middleweight workloads? And should we think about like lightweight as, you know, edge, or how should we start to, you know, how should we characterize that as builders?
I'll kick it off and then I'll let Matt give the detailed version. Good. So I like to think of it as, you know, WebAssembly, or the lightweight, if you will. It is not trying to be everything in the kitchen sink. It's not trying to be the operating system and you know, a full, you know, POSIX environment. It's just trying to be, if not one program, maybe even just one tiny little part of one program, right? It's not attempting to model the entire universe. It is just performing one function, whether that is, you know, offering a set of exported functions that you can call, or just being a sequential program that runs beginning to end. It is attempting to just be that one unit. Whereas the middleweight and the heavyweight, they are everything in the kitchen sink to different layers of intensity. Basically being the operating system and everything that comes along with that, all of its dependencies, a whole bunch of other binaries. It ships with curl, it ships with, you know, a bunch of security and, you know, access models that just aren't necessary when you're at that lightweight. So that's how I'll kick it off, and Matt can take it.
That was great. You did all the heavy lifting, and now I can just tell a story. You know, one of the fascinating things about working at Microsoft when we were working at Azure was being able to sort of see behind the curtain, right? And start to understand how much electricity is consumed, if nothing else, how many racks and racks of servers are being run to execute this stuff. I love pointing to the Andreessen Horowitz cost $1 trillion cost of cloud, $1 trillion paradox, the cost of cloud $1 trillion paradox, where they talk about how expensive it gets as you start to scale a cloud up. And this is something that impacts, you know, small and medium businesses. It's something that definitely impacts enterprises, and it's something that impacts the people operating these data centers like Google and Amazon and DigitalOcean and Azure, right? And that was where that whole lightweight metaphor for me really kind of began to percolate. We started looking at this and saying, well, you know, scale to zero is one problem we can try and solve. And we tried to solve this with containers for years, right? How do we basically say, for those of you familiar with Kubernetes, right? I take an application, it's a single microservice, and I deploy it into Kubernetes. Now, if I'm following best practices, I'm using a deployment, and it's going to schedule 3 to 5 instances of this that are going to get spread out across my node pool. Every single one of those is going to be running 100% of the time because it's slow to start up a container, right? It's seconds to start up a container, and no user's going to hit a website and wait around. Oh, it's probably a container starting up. I'll wait a few seconds. Oh, there's the information, right? So we said, all right, well, how do we get rid of, you know, basically a triplicate copy of every single application that's always running? How do we scale down to zero? Tried it a lot of ways with containers, and we made progress, but never hit anything that we felt was satisfactory. The kind of lightweight thing was when we started to say, okay, is there a different kind of compute that we can use, a different way of executing, you know, bytes that will be more amenable to being able to spin up instantly and shut down just as instantly. And then there is a class of computing problems that we can solve by being able to start these things up, answer a request, shut it down. It can scale down to zero, it can scale up to hundreds of thousands. And if you do it well, then the architecture ends up being still very efficient. That was where, for me, the kind of language of lightweight started to come out. Connor enumerated brilliantly, like all the technical components of this, right? The technical characteristics of it. But the story behind it, I really think, is that we were all looking for ways to make it cheaper to execute our binaries, but still be able to hit those kinds of goals that we have all wanted. You know, the scalability, the kind of being able to support highly redundant or geographically distributed events, or even the way Connor and Liam talked about this a moment ago, bringing compute closer to the data so that you're not shuttling data back and forth across the network just to be able to run a couple of algorithms on it.
And these concerns are in the military referred to as size, weight, and power. And where there's a ton of innovation here, because we have agreed on a common set of standards for runtimes to sort of optimize your code to be executed in for different purposes. So I would point at in the Bytecode Alliance, which is one of the upstream standard organizations. It's a membership org that really drives these standards. Their reference runtime is called Wasm time, and it has a number of modes you can use to sort of prepare your code and pre-position it so that it can load and execute as fast as possible. It also, when it's running on certain operating systems such as Linux, can do things like snapshot your memory, only copy on write, and then rewind back to a clean state. So you can increase your execution cycles for even when you're past scale from 0 into scale from 1 to 100 or 1 to millions. So there's a ton of opportunity for us to take advantage of these unique properties of WebAssembly. It's deny by default, it's portable security model, it's really efficient size and compactness in order to build what we, I think, all collectively think will be the next generation of cloud computing.
Yeah, that's great. Maybe, so in the interest of making sure that we wrap up on time, why don't we just like go around from each panelist, and it'd be cool to hear each person talk about like just like one application where they've seen WebAssembly in the wild that they're like, yeah, this is a the optimal application of this technology, and we're going to see more people doing it this way. And so any of you can start, and we've got you got 2 minutes each. We got 6 minutes left.
Sure, I'll go first. My favorite, I think, is Figma. They even beat us to the punch of being the first ones to put out a production grade plugin system based on WebAssembly. So being able to build in the Figma and FigJam products, plugins that run directly within a user's whiteboard or design session that are completely, there's a contract, there's a defined API that you can take advantage of, different, Figma capabilities, and it's just a WebAssembly module, and so you can imagine the flexibility that it gives plugin developers to be able to write plugins for this very, very popular design application with the languages that they're familiar with, and the benefits that it gives to Figma of greatly growing the ecosystem of their product, allowing people to take advantage of a diverse set of third-party capabilities while still maintaining the safety and the performance that WebAssembly provides. Like when you're working with hundreds of thousands, millions, billions of little vector points on a canvas, you can't be waiting around for JavaScript to slow things down. So throw some C++ in there and let it fly.
And Connor, correct me if I'm wrong, but the developers aren't necessarily creating those applications knowing that they're going to compile the WebAssembly. They're just creating applications. They're just creating plugins, correct?
I think Figma hyped it up a little bit, so everybody knows at this point what it is. But yeah, I mean, the developer of the plugin doesn't need to care. That's one of the beauties of WebAssembly. They just know that there's a defined API with a defined contract. They write to satisfy that contract, and then what happens, during the pipeline to publish it, it doesn't really matter to them.
And this brings us full circle, though. One of the points earlier, which is, it's a language agnostic approach. So the developers can choose their favorite language, build their favorite plugin, and and Figma's laughing all the way to the bank because they've got a bigger and more robust ecosystem as a result. Exactly. And user experience, right? Like all boats rise. Who's next?
I can go next. What I'm most excited about WebAssembly, and this is why, I mean, I'm going to tell you about what Fermyon likes, right? We really think that microservices are sort of ripe for a version 2.0, right? We think there's a chance here to do a refresh on how we think about microservice development. A little while ago, we built a game called Finicky Whiskers that uses seven or 8 different microservices, all built in WebAssembly, and some Docker containers, notably one running Redis. And we wanted to do a couple things. One was illustrate that there's no like WebAssembly versus container thing where we're going to see both of those technologies continue to mature, and there's going to be ways for them to work together. The other was we built a microservice architecture that uses a whole bunch of different languages, builds a little game. The microservices are like 25 to 50 lines of code long. And we wrote it collaboratively in under a week or something like that. And it just really kind of opens up the potential of why we think WebAssembly is going to be able to sort of enable a quicker, faster development experience that is also going to be a quicker and cheaper way to execute these things on the cloud side while still taking advantage of existing technologies like containers. And, we run Redis in a container there and using Nomad for the scheduler and things like that.
Perhaps this leads to a follow-up conversation around, why we need the next generation of microservices. But we're not going to pack that into 2 minutes. Liam, you're up, my friend.
Great. I think, we open sourced Wasm Cloud pretty early. So we've been out for a few years. So we've had multiple times where we get invited on a call from someone and we just get our minds blown. And two of my favorites were probably BMW and Adobe. Maybe I'll tell the BMW story, but BMW and in collaboration with Intel, we're collaborating on running machine learning models for quality assurance on their vehicles before they put them into production. And they were challenged because they were dealing with a complex set of CPUs, developers, clouds that they needed this code to be able to run in. And they had developed the machine learning models independently, but they wanted to design a framework in order to build something. And it really blew my mind, the level of effort that they went to contribute a ton of code back to Wasm Cloud with Intel and some of the developers that had created a WebAssembly project called WasM. And those are the kind of experiences that I think we're all going to continue to have. It's when we see Google Earth, when we see Figma, when we see things that are built using WebAssembly. It's not the goal. It's not the billion-dollar app. It's like HTML. It's going to be part of the technology stack that's used to deliver truly the next generation of amazing experiences from in finance, in development, and go from there.
That's great. Well, thank you, Liam. Thank you, Matt. Thank you, Connor, for this great discussion. And I'm sure that all the folks here and everyone who will watch us in the future appreciates it as well. So with that, we'll wrap it up. Thanks, everyone.
Sorry, I was distracted. I was playing Finicky Whiskers on another tab. See you later.
As you should be.
See you guys. Have a great day.
Yeah.